back to the QST YouTube channel. Today I'll be solving the Term 1 Week 9 Mechanics quiz for grade 11S. Let's go. Which of the following are not field forces? Okay, so look, field forces, I'll just call them FF, is basically action at a distance. Action at, just triple A, let's say. Action at a distance. So not field forces are like the forces that are not field forces are forces that require contact, like normal and tension. Number 2. A wooden block of weight 6 newtons is pulled up an inclined slope by inclination 30 degrees by a force F of magnitude 15 newtons and opposed by a frictional force F of magnitude 2 newtons. Okay, we just take it like this. So first of all, we need to draw the free body diagram, right? So as we know, this is 30. Let's draw the axes in black. I'll make them along the, like, perpendicular to the, what's it called? Perpendicular to the surface and along the surface, like this. So we can project easier, just not make it dotted. Okay. So, from what we can see from the picture, we can see that we have normal up, like this. Normal. To the right here, we have the force F, which is 15. We have friction opposing the motion, which is 2 newtons. Just put it 2. And then down, like just downwards, no need to say the object is here. Straight down is the weight, which is 6 newtons. Now look, so we cannot deal with angled forces and stuff like that. We can say that we're gonna start projecting it. So this is 30. So this force will be W cosine 30. Right? They want it like you can take it as a triangle, you can say. So this would be 30. Let me draw it in another color. This would be the force, and this will be the projected force in X. What would it be with respect to 30? It's adjacent, so it's gonna be cosine. Now there will be another force which will be vertical, right? Which is sine, because this yellow, which is the Y component, is opposite to 30. So we're gonna have over here, like on top of the friction, W sine 30. The question asks for the force, like the sum of the forces on the plane, which is X. Okay, so we're gonna need to first do what? Yeah. Okay, all we need to do is add the forces to the right, subtract the forces from the right from the forces from the left, like the other way around. Sorry, subtract the forces from the left from the forces of the, like, so I'm gonna show you now. So 15 minus, as we said, the weight is 6 minus 6 sine 30. 6 sine 30 plus 2. Make sure to put the 6 sine 30 and 2 in parentheses because it really matters. Now let's do this. 15 minus 6 sine 30 plus 2, which is 10. Yeah, 10's the answer. Number 3. Come on. Okay. 3 forces act on a body as shown in the diagram below. What is the algebraic value of the y component of the net force? Okay, so let me take the free body diagram and the question itself. Okay. Now let's look here. Let's have a look. So here we need to project this force and this force, right? Okay. Here we only care about the y component, so like no need to worry about the x component. So the y component, as we can see here, let's say this is 72. We're talking about the 4.3 newtons, right? Okay. So 7.2, and they want the y component, so it will be vertical. So it will be opposite to the angle, which means it's sine. So this is gonna be 4.3 sine 72. Now let's work with the other force. 3.2 and angle of 45. Same thing. Let's draw the right triangle like this. 45. By the way, to not get confused, this is gonna be equal to like the y axis basically. You could like just do it this way. We need the vertical component, so we need this part, so it will be the opposite, which means we will use sine. So we're gonna do a green arrow here. 3.2 sine 45. But since they want the net force, let's bring this here. Since they want the net force, what we will do, since like it's not only an upward force, there is a downward force, do not forget it. So we're gonna do 3.2 sine 45 plus 4.3 sine 72 minus 2.9. Plug this into the calculator. 3.2 sine 45 plus 4.3 sine 72 minus 2.9, which would give us 3.5, which is the answer. Number 4. Wait. My gosh, what's up with the Wi-Fi today? Okay, the figure below shows a homogeneous block of mass m placed on four identical equally spaced springs of constant k each. The block is in equilibrium. Let's draw the free body diagram of the block. There is the weight, which would be mg. We know the rule from physics from ages ago. And up we will have 4 tension from each of the 4 springs. 1, 2, 3, 4. 40. Okay. Tension is equal to kx by Hooke's law. Okay. So, since the block is equilibrium, let's do sigma Fy is equal to 0. So, 4 tension is equal to mg. So 4kx is equal to mg. Now let's look at what they're looking for. They want the expression for the compression. So they want x only. So we're gonna take 4k to the other side by dividing. So x is equal to mg over 4k, which is what we have here. Number 5. The form of energy liberated by friction is thermal energy, which is heat. A block of weight 4.7 Newton is placed on a rough inclined plane of inclination 37 degrees. The block is held at rest by a massless string under a tension of 1.3 newtons shown below. Okay. Let's take it, add to new page. Okay, let's draw the free body diagram. This is 37. Now, what are the forces that we have? We have weight, we have the normal. Wait, let me first write the axes so nobody gets confused. This will be the x-axis, and perpendicular to it, which is where the normal is, will be the y-axis. Okay, I'll even draw down just in case. They said there is also tension and friction. Wait, is that friction? Yeah, that's friction. So what they want is the normal, right? We can simply just work on the y-axis. Doesn't need to worry that much. We only need to worry about the y-axis. Again, let's do the projection. We have a right triangle like this. This is 37. Never mind. Just let's do it a normal right triangle. Wait. Normal right triangle. This is 37. Alright? We need the y component, which will be, oh my gosh. Okay, look, as we know, this angle is 37, right? Then this is the right angle. So what is the black line to the 37-degree angle? It is adjacent, so it's cosine. So W, so wait, let me do the force here. This is gonna be W cosine 37. They only care about the normal, that's it. So They said, okay, they did not say anything. The block is held at rest. At rest. Held at rest. So that's important to us. Because without it, we would be cooked and we would need to use another method, which we're not gonna need now. So, since it's at rest and we only need the normal, we're gonna work on y. So, we're gonna do sigma fy is equal to 0. So, the normal is gonna be equal to w cosine 37. Then we're gonna plug it into the calculator. They gave us the weight, so all we're gonna do is just 4.7 cosine 37. Wait, cosine 37, that will give us 3.8, which is the answer. Let's erase. Let's move on. Number 7. Let's patiently wait. Okay. Which of the following is a non-inertial frame of reference? Look, a non-inertial frame of reference is basically a frame of reference that is moving with respect to the earth. That's for non-inertial, and it's the other way around for inertial. So basically the only one that's moving, or like accelerating. Stationary means it's at rest. Uniform rectilinear motion means there is no acceleration. Resting means there is no acceleration. The floor, come on, it doesn't move. There is only the rotating wheel which is accelerating. Number 8. Let's keep waiting. Okay. A block is sliding down a frictionless inclined plane as shown in the figure below. Okay. Simply, let's change the color for the... it's not gonna be accurate, but okay. So look, what forces act on it automatically? Since it's on Earth, like not in space, there is gonna be weight. Since it is like on a surface, there will be a normal perpendicular to the surface. There will be normal. They said frictionless, so there is no friction upwards. And that will be it. They didn't say there's any force, nothing. Just normal and weight, which are like this. They didn't ask us to project it, so nothing to worry about. Number 9 is not included. And if it's it's an AP physics question, and if you don't understand the question, like if it's a weird question that we never took before, go to your AQC and talk about it. Or the exam coordinator or officer. 3 springs of the same natural length are length L are deformed by three forces, F1, F2, and F3. The final length of the springs is this. 3 springs is this. Okay, this one I have an easy way to do it, since the final length is the same, right? So that means it's gonna be harder, like you're gonna need more force to deform to change the length of the one with more stiffness, right? So F2 will have the most magnitude, F1 will have less than F2 but more than F3. So, and then F3 has the least magnitude. Number 11. Right. Okay. The inertial mass of the block in the figure 12.5 kilogram. Here, let's just get to the question. The inertial mass of the block is equal to the gravitational mass of the block. It doesn't matter what, when, where, any number, okay? Whether it be a million or 0.0001, the inertial mass of the block will be always equal to the gravitational mass of the block. They're the same thing. Number 12. A 1500 kilogram car is held in place by a light cable on a frictionless ramp. The cable makes an angle of 25 degrees with the surface of the ramp, and the ramp itself rises with 10 degrees at the horizontal. This is genuinely one of the hardest questions. Like, this is the hardest question in the quiz. It's comparable to the second hardest, but this is definitely the hardest. Okay. First, let's draw the surface. They said it rises 10 above the horizontal. So this angle is 10. And then there's tension. And that makes 25 degrees with the ramp. So this is 25. Right? Okay. Let's say this is the object. Now let's draw the axes. X-axis. No. Let's draw it like this. X-axis, Y-axis. Okay. So now we're gonna have the normal, of course. Wait, not in green. Let's make it blue. We're gonna have the normal here. We're gonna have tension here. We're gonna have weight downwards. And we don't have friction. So these are the only forces. But we're gonna need to project the tension. So let's do this. This is 25. So let's say we want the horizontal component, which will be this part, right? So we're gonna do 10 t cosine. So this is t cosine 25. And then there will be a vertical component. Since it's opposite to the 25, it's gonna be t sine 25. Now let's look at the question and what they want. They want the tension and the normal. They want t and n. Okay. Oh wait, by the way, I completely forgot to project the weight. Okay, so again we're gonna do the same thing. This is 10. As we already know, I think you guys should know it by now. This is W cosine 10, and this is gonna be W sine 10. Okay, now let's find the tension first. Let's do it a simple way and use sigma fx is equal to 0. Sigma fx. Let me just wait. No. Like this. Sigma fx is equal to 0. So double the weight times sine 10 is equal to t cosine 25. Let me change colors for why not. The weight is 50. Wait, let me check what they used. Well, let's weight is mg, so mass times g, which will take as 10. So 15,000. Wait, gonna erase this line. It's annoying. T, we said cosine 25. So 15,000 sine 10 is equal to T cosine, wait, is equal to T cosine 25. So what we're gonna do is do 15,000 sine 10 over cosine 25. Let's plug this into the calculator. 15,000 sine 10 over cosine 25, which will give us 2874, right? Correct. Now we want the normal. Okay, so again we're gonna use sigma fy now. Sigma fy is equal to 0. Now what we're gonna do is up minus down. Up is equal to down, right? So normal plus t sine 25 is equal to w cosine 10. Wait. Okay. So normal is equal to 15,000 cosine 10 minus 2874 sine 25. And then let's substitute. Let's plug this into the calculator. Sorry, 15,000 cosine 10 minus 2874 sine 25. Right. Yeah, we'll get 13,558. Let's erase this. Can't I erase? Let's just add a new page. Number 13. Okay, this is the second hardest question in the quiz. A load hangs in equilibrium using two cables that form an angle of 120 degrees shown below. The force of gravity acting on the load is 590. First, let's sketch the free body diagram. Here we have the object. Let's draw the x and y axis. This time it's normal for once. Okay. So to the right, we have tension of BC. Tension of BC. And then down we have the weight, which is 519. And we have up here tension of AC. Now look, they said this whole thing is 120, right? So, right, let's draw perpendicular here. So this part, let me make it in red. this part will be 30, right? But we will need it to the x-axis, so this will be 60. So we will use 60. I could use both, but I'm gonna use 60 since it's easy. 60. Wait, just put it inside. 60. Okay. Then we're gonna project it as always. TAC. This is 60. We want, so let's say we need this, so we're gonna use cosine. So let's do it in blue. TAC cosine 60. Am I right? Then up here we'll do the opposite, like there is no other way. T sine 60. TAC, like they're different tensions, so we don't get confused. Now they want the tension in AC and what's it called? BC. So first we can do simply, let's erase this. We can simply do sigma fx, I mean fy, sorry, is equal to 0. So T sine 60 is equal to the weight. TAC, be specific guys, so you do not get lost. TAC. So we're just gonna do TAC is equal to 519 over sine 60. So again, 519 over sine 60, which will give us 599.28. I don't know why it's 600. Like, there has to be something wrong with the quiz, because there is no chance that it should be like this. Anyways, now we can do part B by finding tension in BC. Okay, so now we're gonna do sigma fx is equal to 0. So TAC cosine 60 is equal to tension in BC, right? Okay, so 600 cosine 60. 600 cosine 60 is tension in BC. You get tension in BC is 300, which is what we have here. Number 14. Okay, this is easy, come on guys. The direction of the force exerted by the ball on the wall. So let's say like they said it here in the diagram below, a ball B, it's a wall W with the force. There is no other way. It cannot to the left, it cannot up, it cannot down, so it's just simply to the right. Okay, the direction of the reaction will be the opposite direction of part A, so it will be to the left. Number 15. Come on. A 60 kilogram skier descends from a hill. At the bottom of the hill, the speed of the skier is 10 meters per second. At that moment, the skier continues to move horizontally for 40 seconds before stopping. Take G is equal to 10. Okay. So let's solve this. Let's say there's a hill here, right? And the floor here, which is the part we're trying to like calculate in. Let's say at this point, V initial is 10, right? And the bottom of the hill, the speed of the skier is 10. And then at that moment, the skier continues to move horizontally before stopping. So let's say here V final is equal to 0. Okay, so now let's draw the free body diagram of the skier. We have, as always, normal, down is weight, and we have friction opposing the motion, which is to the left, kinetic friction, since the object is moving. Okay, so they want the friction. Okay, so we can do, since it's only moving in the x-axis, sigma f x is equal to ma. Friction, kinetic friction, is equal to 60 times, we can do V final minus V initial over time, yeah, 0 minus 10 over the time which they gave as 40. Okay, 0 minus 10 over 40. By the way, friction is negative because it's opposing the motion. Okay, so you'll get friction is 15. Now you may ask, how do we get the coefficient of friction? And you may ask, some of you may even ask, what even is the coefficient of friction? So look, let me introduce you to the rule of friction. Friction is equal to the coefficient times the normal, right? Okay, but we need the normal. Now how do we find the normal? We're gonna do sigma fy is equal to 0. Since there is no acceleration in y, we can equate it to 0. So normal is equal to weight. Normal is equal to 600. We have the mass of the skier. They gave it 60 and they said G is 10. So the normal is 600. So friction, which is 15, is equal to the coefficient times 600. You'll get the coefficient is 0.025. Which is what we have here. Last and final question for today's video. The diagram below shows two forces, F1 and F2, of magnitudes 40 and 30 respectively. Okay. Now this is hard, but we're gonna need to relate it to vectors. Just bring everything up. Okay. Let's do the free body diagram so we can... Actually, there is no need to. We can just do it on here. Okay. Let's say we want to project F2, right? So we can make it into X and Y. So here, which will be like coinciding with F1, we would have cosine. So we're gonna do here force. Let's make it smaller. F2 cosine 45. Let's make it green like this. So the second one, which would be this one, would be F2 sine 45. Now guys, if you remember vectors, like from the start of the year, or if you remember vectors, how did we used to find the magnitude? We would do radical x component squared plus radical y component squared. So what is the x component? So we're gonna add the x component. Okay, we have f2 cosine 45, which is 30 cosine 45 plus, don't forget to add the 40 because it's also an x component, by f1, 40 all of that squared plus 30 sine 45 squared. Plug that into the calculator. 30 plus cosine 45, 30 cosine 45 plus 40, all of that squared, plus 30 sine 45, all of that squared. That will give us 64.8, which is correct. And now they want the angle which makes it positive. Also, remember from vectors, we would do tan inverse y over x for direction, right? Which is what we're doing here. So what we're gonna do is, instead of y over x, we're gonna use the components. So tan inverse f2 sine 45, f2 substituted by 30, so 30 sine 45 over 40 plus 30 cosine 45, and you'll get 19.1. Okay guys, that's it for the video. Thank you guys so much for watching this. Good luck with your exams and goodbye.